The Sustainability Now Telesummit is honored to share audacious ideas and innovative solutions from more than 30 experts from around the globe. Learn how we can work together to shape a world that works. Here's your host, Mira Rubin.
Welcome back to the Sustainability Now Telesummit, Shaping a World That Works. I'm so excited to introduce Hajjar Gibran, who is a brilliant designer and inventor, and who has pioneered the use of a material called AirCrete. Well, he's coined the term AirCrete to build in the residential context or non-industrial context, and makes the most spectacularly beautiful structures for living and whatever else we want to apply them to. So Hajjar, I am so delighted to have you with us. Thank you so much for being here.
Well, thank you, Mara. It's a pleasure to be here with you, and thanks for that wonderful introduction.
Well, it's all true. I just revere what you do. It's extraordinary. And so you're here today, or you're here on this summit to share with us how you build with AirCrete and what it is and why we would want to, right? So could you
give you a basic introduction anyway?
Perfect. So how about if you just start out telling us what is AirCrete?
Well, it's a material that's actually been around a long time. There's even signs that it was used in the Roman Empire, but the recipe was lost. And about 100 years ago, it was reinvented in Scandinavia. In the industry, it's called cellular concrete or aerated concrete or foam concrete. And I coined the term AirCrete when I decided to make it available to the do-it-yourself builder. Until now, it's been really just available on an industrial scale with industrial equipment that was very expensive. But it's a very simple material. It's just cement powder mixed with water and a foam that's made out of non-toxic dish detergent is the way we make it. There are other foaming agents you can use, of course. And then you mix the foam in with the slurry of cement and water, and it creates this really lightweight, cementitious material that has the qualities of concrete, or a lot of amazing qualities of concrete, without the weight and without the cost. And it's super easy to work with. You can cut it and shape it with woodworking tools or hand tools. You can carve it with a spoon. Wow. And it's easy to make. Just mixing these, it's kind of like making pancake batter in a way, mixing whipped cream into the flour and water. It doesn't rot or decay. It doesn't corrode. It's fireproof and waterproof and termite, insect proof. So it's just a really wonderful material that I'm amazed I hadn't heard of it as a builder until I was in my 50s. And so once I discovered it, I realized it was the material that I was looking for to create low-cost housing.
So I hadn't heard of it until I found you, actually.
Yeah, no, so many people have never heard of it. It's actually fairly well known in other parts of the world, like in Scandinavia.
Really? So you discovered this AirCrete. You talked about your mission really to find a way to create low-cost housing. And right. So let's just look at the practical aspect of this and do a price comparison. For instance, like how much would you be able to build an AirCrete dome home for?
Well, the material cost is very low. It's about $1 per square foot per inch of thickness. So for instance, if you were building 1,000 square foot building and you made your walls 4 inches thick, it would cost about $4,000 for the materials. And that includes your foundation slab, the finished walls with your archways and window openings, and with a reinforcing skin on it. It wouldn't include any of the finishing, like it wouldn't be the finished floor or any of your plumbing and electrical fixtures or windows or doors, but it would be the finished AirCrete structure.
I'm going to pause for a second because I'm wondering if there's a way for you to put, I'm guessing you have your laptop on your lap.
Yeah.
Is there a way to put it on something stable? Because we're getting some movement.
Oh, okay. Let me get a table. Let's see. I mean, I could, here, I'll sit in at my desk. That would be much better. How's that?
Okay, it's not as cool a background, but it's fine. And now just tilt the top down to you a little bit more. Yeah, that's good. And I wonder if people will pick up. We'll cut away to a picture or something in between, and we'll fit. And I wonder if people will recognize that you're in a different place.
Hey, doesn't matter really, probably.
No, it doesn't. Okay, so where were we? We were talking about cost. So one of the things that I think is a concern, and I want to sort of address it with folks up front, is permitting issues for buildings, because this is an unusual method, at least in the US. It's not a standardized method. And so folks that are interested in building a dome home or out of AirCrete are going to want to make sure that they get all the appropriate inspections, and you can give us maybe some insight in what we need to look for.
Well, you know, unconventional structures are built all the time. And it's the standard process is if it isn't covered by the building code, then it needs an engineer's stamp of approval. And that releases the county from liability. And so that's basically what you're dealing with. If you want to build a permitted structure, then you'll need an engineer that's licensed in your county to approve it, until such time where we've gotten the ICC approval, but those kind of processes are going to take time. I think, it's a pretty easy thing for an engineer to analyze. Domes are very easy to analyze because the forces are all distributed equally. It's it's probably actually the simplest structure there is, and inherent strength in the shape. So, but if you want to get a permit, you'll need to get an engineer involved, and that's true with anything you're going to build that isn't covered under the code.
Right. Well, I just wanted to get that out of the way before we got into the nitty-gritty of how to build a dome. And I just want to say up front too that you are generously including a handbook that incorporates all kinds of very specific instructions and lists of materials as part of the gift that's included in the summit package that is available for purchase. So folks that decide that they want to archive our content can purchase the summit package, and as part of that package they'll be receiving the handbook for how to build these domes. So because the reason I'm saying that is because there's only so much information we can go through here and now. And while we'll give you enough to be dangerous, there's still going to be some nuances that you might need to be able to really build one of these things. And also, I just want to say that Hajjar offers these wonderful courses where you can do hands-on and actually build these structures. So, okay. Now let's get rocking and rolling. How do you actually plan for one of these domes, Hajjar? If we want to, let's say I have a piece of land, I want to build a dome. How do I start?
Well, if you got the land, you want to build a dome, decide where you want to build a dome.
And are there certain things that I need to be particularly attentive to that I wouldn't have to be for other kinds of structures, or is it pretty standard all the way around?
No, it's not really standard. It's much simpler.
Okay.
Things you want to know are, what are your setback requirements? So know your property line and make sure you're building in,
Okay.
you're not encroaching on your setbacks.
Right.
So that if you ever do want to get the building permitted. And then, you want to understand the conditions of the ground that you're going to build upon. For instance, if you're building in Alaska where you get permafrost and or in any cold climate, the foundation is going to be different than if you build, say, on a lava bed here in Hawaii. So, so these are the kind of things. If you're not comfortable with your own analysis of your situation, you might want to bring in a local builder or an engineer to just assess what you might need for a foundation. We build our foundations out of AirCrete also, and most of our building is in the tropics, so and on stable ground. Like I like to build on the ground and without disturbing it,
Okay.
because if you've got stable ground, you'll have a stable building. But if you disturb the ground or if you bring in fresh soil or fresh bedding for your building, then that's probably going to settle in time. I mean, you can tamp it and build. So anyway, there's a million ways to consider the requirements for your foundation.
Okay.
Because my focus is on low cost, I'm a minimalist. And I look at, well, what is the minimum that I need to do to create a stable foundation for my building? And so we typically will just create a level trench and then pour a ring beam in that trench. That's the diameter of our dome. And then we'll pour AirCrete slab over that. And then we build right on top of that.
Okay, great. And so you've chosen your area that you're going to build your dome. And then what? Do you map out you have to create the area for the foundation? And
well, actually, the first thing we do is, design your dome on paper first. Decide, but look at your land and see how big of a dome can you put on the spot that you're going to put there. What are you going to use the building for? Is there going to be more than one dome, more than one room? We typically make a dome for every room rather than dividing a big dome up into smaller rooms. But you can build a big dome and divide it up into smaller rooms, or you can build different size domes. Yeah, so there's a lot of different ways of doing it, and there's if you're going to have multiple domes, there's different ways of clustering the domes together. They can interface with each other, or they can be connected by archways, and they can be at different levels. If your ground isn't level, it's nice to build your rooms on different levels. It creates, to me, a really interesting space. And it makes it much easier too, rather than excavating your building site level. Just put your domes at different levels, even if it's just a few inches.
very cool.
Like Steve's dome, each room is at a different level. So anyway, once you decide the size of your dome, then all you need is what we call a compass arm. That's the length of the radius of the dome. And we like to raise our domes off, so the center of the sphere is actually off the ground about 3 feet. That way, when the dome comes out of the ground, it expands out. So, and about 3 feet high, it's its widest, so that when you walk into the wall of the dome, your feet hit the same time as your head would hit, rather than having it curve in on you. If the center was at the ground level, then the walls come in. And to me, that's, you can use that space as storage or whatever, but to me, it's not as aesthetically pleasing, and it's not as comfortable. It's nice to sit on the floor and lean against your wall, and it actually leans out. or even if you're at chair height, it still leans out, so you can put a bench in there.
Nice.
So what you need in order to build your dome 3 feet high, you need a stand for your compass arm that's 3 feet high, so that you have this compass arm that pivots around the center of the sphere 3 feet off the ground, and that defines your dome. You don't have to measure anything or level anything. That compass arm tells you where to put your bricks, and you can do it with your eyes closed.
Beautiful. So that it ends up being very precise.
Yeah, it's very precise without really much skill. A child can do it.
So we've got the compass arm, and we're using that before we pour the foundation, or is that helping us to see where the foundation goes?
Yeah, exactly. So the first thing that goes in the ground is either a tripod or a pole in the ground to support your compass arm. That tells you where the foundation perimeter is, and it guides you when you're laying your blocks. It also, before we lay any blocks, we put the arches up. We usually put arches around our doorways. I really like to put arches all the way around the building and then just cover the arches with the dome. But you can decide how many arches you want, but the arches go in before the dome gets built. In our workshops, we usually only build 1 or maybe 2 arches, just because we've got 10 days to finish the building. And if we were going to build, say, 5 arches all the way around, we would have to build 5 forms so we could do all the arches at once. But if you were doing it yourself and you wanted arches all the way around, you just need 1 form. And then every day you could build an arch. And then after 5 days, you could start building your dome. But when you put an arch in, you're actually creating a flat vertical surface in your dome. Under the arch, it'll be flat and vertical. So, then it's easy to put a doorway in, or you can put a window in, or it can just be a wall. It could be a closet. It could be a place where you put a desk or a sofa. It makes the living space much more compatible to furniture and stuff like that.
Because you have some flat walls.
Yes.
Okay. All right, good. So by putting arches all the way around, you're kind of future-proofing it, because you could always dig into those sides if you wanted to connect another dome. Is that true?
Yeah, but you can connect another dome right to an existing dome also.
Okay. Okay, good.
You don't really need the arch.
So now to build those arches, you outline that pretty clearly in the handbook, but what you're doing is you're building a form first, right?
Yes, we use EMT, electrical metal tubing, which is a very inexpensive but strong zinc-coated metal tube that and very readily available all over the world. And we have a special bender that bends that into the shape that we want for our arch. And then we connect that with some wood pieces that are screwed to it and then covered with thin plywood. And then we just put our blocks right on top of that. And then that form comes out and is reusable over and over again.
Okay. And so what kind of things do we want to consider when we're putting in this arch? How tall does it have to be, or how wide, or how do we construct it?
Yeah, you want it tall enough for a doorway.
That makes sense.
It depends. Arches can be all kinds of size. Arch could just be a small window even. Okay. Or it could be 2 stories tall.
Okay.
Or your arch could actually be your building. It doesn't have to be a dome. You can live under a big arch. Or the arch could extend out from the dome and be a room in itself.
So one of the beauties of this material is that it's so malleable. I mean, you can form it so readily by sawing it or shaping it, as you said, with a rasp or whatever. It's sculptural, right?
Yeah, it is.
And so the question is, what gives it its strength? And you mentioned a covering. So let's talk about that, and then we'll back up into how you would build this dome once you have the foundation poured and all of that.
Okay. Well, AirCrete itself, like concrete, is brittle. and it cracks. It has good compression strength. You can, for instance, drive a truck on it and it'll support the weight. So it's good compression strength. But if it'll crack if you, put forces pulling it. And so there's basically the two forces that act on something: tensile forces and compression forces, pushing and pulling. And so cracking happens when the material's pulled apart. And so what we do is we laminate a reinforcing skin to the outer surface of the building, and that gives it a tensile membrane, something that won't crack on the surface, because that's, if you can stop the surface from cracking, that's all you really need. It's very similar to, the way, think about a piece of sheetrock. It's made out of gypsum, which is also a very brittle material, but it has a piece of paper laminated to the surface on both sides. And because of the paper, it's actually a pretty strong board. It doesn't break easily, but you cut through the paper and there's very little strength there. Right. It's the same thing with AirCrete, or you could think of a surfboard, how it just has a foam core inside that you could never surf on, but you put a tensile membrane of fiberglass over it, and you have a really strong building material. Or an airplane wing is a torsion box. That's the engineering term. It's called a torsion box when you have a tensile membrane over a form. An airplane wing or a hollow core door. All that's in the hollow core door is cardboard on edge to hold the form. Right. Then the thin layers of plywood create a torsion box. They're the tensile membrane over the cardboard core, and makes a very strong structure. And so that's the way we build our domes. They have the AirCrete creates the form, and then the tensile membrane laminated on the surface gives you the structural integrity that you need, both the tensile strength and the compression strength.
Okay, great. So here we are. We've got our foundation. We've got our arches. And we're mounting the arches by using some kind of AirCrete slurry or mortar?
Yeah, well, there's different ways you can do it. The way we teach in the workshops, which is the most basic way, we put up the arch form and then we make blocks out of AirCrete, and then we just lay the blocks over the form. What we do is we pour a slab, usually 4 foot by 8 foot.
And you make a form to pour the slab. Okay.
You make a form, and you do it different ways depending on the conditions and the materials available. But my favorite way is to make the slab like 12 inches thick, and then we slice that into blocks. And there's different ways that we've done it. In the beginning, we made forms and made the blocks triangle shaped, and they're with the curvature of the dome already in them. And then we made forms for tapered blocks that nestled together where all the sides pointed towards the center. And now we've gotten into where we just make simple forms, and we use a cookie cutter method to cut them into blocks. And we're experimenting with cutting with a wire now too. And I feel like that's going to be the best, because the problem with forms is you have to make them, you have to store them, you have to clean them, you have to oil them. There's a lot of processes, whereas if you could just pour a slab and then slice it with a wire into blocks, you don't have all that material to clean and to oil. And so it's more a matter of timing, making sure you've got it's cured at the right rate where you can slice it. And it's not too soon, so it doesn't bond back together, but it's not too late, so it's too hard to cut. So anyway, we're still working on that method, but I think we'll be teaching that probably in one of our next workshops.
So we have poured a slab, and we've cut these blocks. Now what? And you said we'll use the compass arm in order to place the blocks at the right location. Yeah.
Exactly. Yeah. The compass arm has a little stop on the end that, basically you just locate the block up against that stop, and then it sits in mortar, and they're mortared to each other with an AirCrete mortar. And as you go up, once you get several layers up above the perimeter or the equator, where the widest part, then they start leaning in. And so the block actually wants to fall in. So we put a weight on it. With a hook, with a string, with a bottle of water tied to it, and that stabilizes it.
On the outside.
On the outside, yeah.
So we've placed the forms, and now we're going to be putting the bricks around them.
Exactly. And they just basically stack. They're easy to cut. We just use a handsaw to cut them. And if they're not cut precisely, it doesn't really matter. You can just inject some mortar in there. And we have a giant syringe that we use. You can suck up the AirCrete and then inject it wherever you need it. And so it's very user friendly. That's what I mean, that children can do it. It doesn't take precision, even though you end up with a really precise structure. There's a lot of room for fudging, and if you make mistakes, it's not critical. Something's cut too short, no problem.
You just fill it in with another piece.
Just fill it in, and and if the building, once you've laid up all the blocks, it's fairly rough on the outside and inside because you're using rectangular blocks to do a round curved surface, and so the corners stick out. But we have a rasp, and you just basically shape all the rough spots off until you have a nice smooth surface, and then you apply the fabric reinforcing skin on it. And so it's fairly easy to get a really nice looking shape.
So let's back up a little bit to being putting these bricks on. You had said initially the curve is going out, right?
Oh, when it comes off the ground.
When it's coming off the ground. So are you building in layers? Are you building in entire cycles?
Yeah, well, if you have arches all the way around, then you're just building between the arches until you get on top of the arches.
Okay.
But if there's no arches, like say you're going to build a swimming pool this way, when you could, then you just go all the way around.
Okay.
Layers, and then wrap it with the reinforcing fabric. If there's a swimming pool, you probably want to put a few layers of the fabric around. The fabric's very inexpensive. We use different fabrics, but one of the most popular ones we use is a polyester roofing fabric, a reinforcing fabric designed for reinforcing roofing. And you can get 1,000 square feet of it for $150.
Wow. And
so you could wrap a 20-foot diameter swimming pool several times with that. It's 325 feet long.
Wow. Wow.
40 inches wide.
How about that?
Yeah, so anyway, it's a really cool building system that doesn't cost much, but has, amazing strength and durability, longevity, and it's easy to do.
So for all the windows and all the doors and whatever openings, you need to have an already built support that's distinct from the bricks, or not?
A lot of different ways to do windows.
Okay.
For instance, you could put an archway, just like you would a door, build a flat wall under the arch and put a standard window in it. Or you could just cut the shape of the window that you want into the side of the dome. So let's say, this is one of the nicest and simplest ways. Have a flat windowsill on the bottom and then a round, here I'll try to, a round window opening above it. And then inside the cutout, put a piece of thin material like masonite or sheet metal or thin plywood. Cut it so it fits tight inside that opening, and then that will support your bricks. And then you just brick that up, and then put your reinforcing fabric to, tie it all together, and you have a beautiful window opening. And then you could make a custom window to go in that, or you could make a standard window, put a standard window in there, and just AirCrete around it. Yeah,
Wow.
Yeah, it's really, whatever you can imagine, you can practically do with AirCrete.
So how long does it take for the AirCrete to set up when you're casting the blocks?
Just overnight. Like we'll pour the blocks one day and start building with them the next. They're pretty fragile still, but you can build with them.
So being that they're fragile, are you creating some kind of enclosure to be able to build this whole thing out? Protect whatever you're pouring or whatever you're building? Or is it okay to have it exposed to the elements?
You don't have to protect the AirCrete from moisture. Actually, moisture is good for it. It's even a good idea to keep it wet.
And why is that?
Well, the curing process is a chemical reaction that requires water. If you notice, anytime something's built out of concrete, they'll cover it and they'll keep it wet because it's real important. If it's dry out, like sometimes we'll build in the desert, and so we'll keep it covered and we'll hose it down for the first few days, making sure it's kept wet. So you don't have to protect it from the rain, except when it's, maybe for the first few hours before it's hardened enough. But after that, it doesn't matter. But if you're building and it's raining, you want to protect yourself from the rain.
Sure.
So, in your tools.
Okay.
Yeah, but the material itself doesn't need to be protected from the rain.
Okay. So are you mortaring as you're putting in a new course of bricks? Are you mortaring every course as you go?
Yeah. Yes.
Are you mortaring every brick? So every time you're going to place a new brick, you're putting in mortar?
Yes.
Okay.
Yeah.
Okay.
Yeah, we don't put that much mortar because we like to, like for instance, on the outside of the dome, we don't want the mortar to ooze out. And then we'll fill, after we've shaped the dome, then we'll fill the spaces between the bricks on the outside. So it's just enough mortar to keep everything stable.
Okay. So this material is pretty fragile initially. I mean, it's delicate. It will be easy to mar. So we're building up, and then we're starting to build in, and eventually we're building closed. But you said the way that you hold the curve is with weighted bottles or bottles of water that are hanging as weights on the outside. Is that accurate?
Yeah, exactly.
So you're building from the inside?
Yes.
And how, I maybe you can just describe that process a little bit more in depth for us too, because I'm thinking, how do you get up to the place where you need to put the bricks up inside?
We use scaffolding.
Okay.
We have scaffolding on wheels so you can roll it around, or ladders. But yeah, it's nice to be up above the level that you're actually working on.
Okay.
Yeah, because you can do work from the outside too, to some extent, but when you get up that high, it's really impractical to work from the outside.
Okay. And can you describe how you would create the weighting system? How does that work? What's anchoring the weights?
It's just can be as simple as a nail with a piece of string tied to it, and on the other end is a bottle of water.
And you're nailing that right into the brick?
Yeah, you just push the nail into the brick, and then the weight keeps the brick from falling in. And then when you get to the next row, as you come to the nail, you just lift the nail up and put it in the brick that you're putting on top of it.
Okay.
So, yeah.
So for every brick that you're placing, you've got a bottle suspended on the outside.
Yeah. Yeah. And when you get up to the very top, you might even have 2 bottles on it.
Okay.
Now you can hold the brick completely horizontal that way.
That's remarkable. And it's not something that I think would be obvious to people that are thinking about, well, how do you build this thing?
I know. Actually, I experimented with several methods before I finally figured that out, and it works great.
Right. And at the top, you've got an opening, and that opening, what are you doing with the opening? And tell us the function of that.
Building the tropics, it's really important to have good ventilation. And so we always put a vented skylight right in the center that lets the hot air out and also lets in natural lighting. And so we'll usually have at least a 3 to 4 foot hole in the top of the dome. And but we don't always do that. If you want to close it up, one of the ways we've done it, which is kind of fun, is like we'll put a big window, big round window, like maybe 6 foot diameter window, but we'll build the dome and then cut out the 6 foot diameter hole, and then we'll use that piece as the cap of the dome, and that works really nice.
Beautiful. So, okay, we've built the whole thing, and now it's time to cover it. How do you get up to the top to be able to cover it?
Well, you can, we'll use ladders, and you can, once it's all built, you can stand on it.
Oh, it won't hurt it?
No, it's very strong. You mean to put on the skin?
Yes.
Yeah, well, that we do from the ground up. We just, like once we've gone up, like the fabric we use is typically 40 inches wide. So once we've gone up that far, we put a roll of fabric on. And then once we've gone up another one, we'll put the fabric, shape it and put the fabric as we go up. So as we go up, the dome becomes very strong. And then, we can lean ladders against it. We can put scaffolding up, or we can climb right on the dome once it's, up to the top.
Maybe you could walk us through some of those pieces that we may have forgotten.
Well, it is, there's kind of a lot there to kind of go over, but it's,
There is.
Yeah, it's starting out with gathering your equipment and materials and tools, and then raising a canopy over your site if you need to protect yourself from the elements, building your blocks, building your arch form, building your skylight, building windowsills and forms, building your door. Yeah, we start building our front door right away at the beginning of our workshops, because we build the door frame around the actual door so we get a really precise fit.
Oh, that's interesting.
Yeah.
So you're building the door out of AirCrete bricks as well?
No, we make a solid wood oval door.
Oh, wow.
And then we pour a reinforced concrete door frame around that with a door stop and everything built into it. And it fits, precisely, because we'll put a thin piece of material between the door and the door frame, and then we remove that later. So it leaves like a 1/16 of an inch all the way around the door, and with a door stop. Sometimes we'll make the doors a big door, like 5 foot wide, with a pivot in the center. Or
I've seen these, beautiful. They're rather magical.
yeah, it's one of our signature things. That I feel like that's what kind of sets us apart, is we have beautiful, precise forms, shapes of our buildings, and we have oval and round doors and windows. We would never put a square window in our buildings, but you can if you need to. But we like, we've developed ways of making round and oval windows and doors that are pretty simple and that work really well. And that's one of the things that we teach.
So that's within your workshop is how long?
Typically 10 days. Yeah, sometimes during our longer workshops, we'll do a one-day workshop that we let our students teach to the locals. And, so we bring people in for one day and just give them a complete overview of what's happening. So they don't get a lot of hands-on experience, but they actually get to witness the process.
Now, you also certify people to be able to give your workshops, don't you? So there may be people that are watching and listening that would be really interested in getting certified to do that.
Yeah, there's a growing and big demand for people who know how to build in this way, because a lot of people are wanting to build with AirCrete, and they're wanting to build the type of structures that we build, and so there's definitely a lot of need. We have a community, a global community forum where people from all over the world post requests for help and also offer their skills. If you've attended one of our workshops, then you can let people know that you've attended the workshop and what your skills are and what you're looking for. Some people just want to volunteer for more experience. Other people are, professional builders, and they're offering their services at a charge. And there's a lot of opportunity.
So there's no question there's a lot of opportunity, and particularly because of the cost factor. I mean, the beauty factor is a big deal, but the cost factor and the ease of building, as you said in another conversation, a child could build with this material. I mean, in terms of strength, you don't need to have a lot of physical strength to be able to build with this.
No. And you don't need a lot of skill either. It's something that anyone can learn.
So in your 10-day workshop, what actually are you doing? You're building a door, you're building the structure, and I guess you're facing that structure as well?
Yeah, like we'll usually have the foundation already prepared for us, and then we show up and right away we'll build the forms for the blocks. We'll start pouring blocks. We'll make our arch form. The next day we'll build our arch, and we'll start building the wooden door while we're building more blocks, and then we'll start building the dome. And within 10 days we'll have the dome finished with the reinforcing skin on it, with the front door functioning and working, the round windows in place, everything finished. With the skylight, we'll also build the skylight and install that. The interior will be unfinished, but it's basically ready for paint or whatever. It's going to be the finish coating.
And as far as wiring or plumbing and things like that?
Yeah, we like if there's going to be any plumbing in the building, then all the drains will already be installed in the foundation floor. And we do teach basic electrical and plumbing installation, but we may install some boxes and outlets during a 10-day workshop, but the completing will happen later.
And you also have a program where people can host a building. Is that true? Or are you still doing that?
We've been doing that. We've been doing that all over the place, but we just got our own property here in Hawaii, and I think we're going to focus more on doing our trainings here. We can offer a much better training in our own facilities. We don't have to start from square one every time. And we're developing some more advanced methods that we want to teach too. And so I think we're going to be doing less workshops away from here and more of them here. But we're just kind of getting that set up now.
Wonderful. So people can actually come and learn to build dome buildings and visit Hawaii all at the same time.
Yeah, exactly. And then once you learn the method, you can host your own workshop for your own community.
Right. So is the certification program something that's distinct from the 10-day workshop, or are they one and the same?
Yeah, what we did last year was we invited people who did the 10-day workshop to come to a month-long certification training. And there were some people who were part of that hadn't done the 10-day, but they had prior building experience.
Mm-hmm.
So it's a pretty, it is, we don't have any like hard and fast rules of how that happens. Some people can just watch our videos or look at our pictures and start a professional career without even taking our training, just buying the equipment. Other people need a lot more experience and training to get to that level.
And that's actually something I want to point out too, is that you do make a bunch of this equipment available for sale.
Yeah, that's a big part of how we finance everything that we do, is through the sale of our equipment.
Which is a perfect segue into how can people support what you're up to. And actually, we talked about this being a mission to create a low cost housing alternative. Is there more about your mission that you'd like to state and share?
Yes, I mean, it isn't just about low cost. It's about offering, to me, a wiser method of building, an alternative, because we've pretty much destroyed so much of the natural ecosystems and the forests anyway for the lumber industry. And I feel for me personally, I was part of that because I used to build a lot with wood, and it really broke my heart when I realized that the ecosystems that I held as sacred were being mowed down. And so that was really the main motive that started me on this journey. It wasn't so much just the low cost, it was doing something other than cutting down our forests. And I just think we can build a lot smarter and for a lot less cost than we are. And so I feel like, we really are pioneering a system that has a lot of merit, and I want to see it become more mainstream. And so that's what we're doing our best, and I know it's going to take time to get through all the especially permitting processes before it'll be an accepted, permitted system of building. But who knows? It might be quicker than I imagine. But the more people who get on board with it, who start doing it, the more buildings that are built, the more professional architects and engineers and builders who get involved, the faster it's going to be.
So that's the call to everyone that's listening, and share it widely. This is a beautiful solution, and I don't think we talked about internal temperatures and energy consumption in these kinds of buildings. So can we just address that real quickly before we wrap up?
Yeah, like we're getting one permitted in North Carolina, and the county is requiring that it's 8 inches thick to have to meet their requirements for insulation. And so, there's a lot of variations of what you can do. Here in the tropics, we only build like 4 inches thick. In Alaska, you might want to make it a foot thick, or maybe you want to do like a straw bale house is 2 feet thick. So you can do what I really want to do is just encourage people to learn how to work with this material and start, there's so many different things you can do with it. I know I have a friend who just built a porch in his backyard, and he got his 2x6 and plywood and built this deck and everything. And I realized that, man, if he knew how to build with AirCrete, he would have just framed out a form and just poured some AirCrete in there. It would have been way more practical and cost him much less, and would have been a lot easier. And so it's just it's a really versatile material that's easy to work with and has a lot of great qualities. And so it's and you can build $1 million luxury home with it and have a super high quality building that will be, I'm trying to try to answer the question you just gave about, I think it was about heating and cooling and ventilation and air circulation.
Yes.
All of that can be incorporated into your design. Domes have a natural flow of convection currents, and designing with skylights in the apex of the dome and openings, you can create a lot of really great ventilation if ventilation is what you want. If you need a more cozy building that's going to get you through a winter in Alaska, then you can bury the thing in the ground too, because it's super strong. It'll take the weight and it's not going to rot if it's up against moisture. So it's, it's an amazing material, and it's really easy to work with. I think we more or less covered it.
Okay, good.
Yeah. Because just talking about it is really such a basic introduction.
Sure.
You want to learn more, get the equipment, start playing with it, or attend a workshop. One of the things that we offer is we have a foam generator for creating the foam, and we have a foam injection mixer. And that if you buy both of those through our store, we give you our architectural drawings for Steve's dome home, this cluster of 3 domes that most people is what draw them to our website. And our instruction manual comes with that too. So with the foam generator and the mixer and the instruction manual and the architectural drawings, you kind of have, what you need to start building. And you might want to just start by building something simple and small first. Or you might just dive into it. We have, there's one young 19-year-old kid from Argentina who had never built anything, came to one of our workshops, and now he's building professionally. He's built over 9 domes already.
Wow.
Kind of amazing.
It's amazing.
Yeah.
He found his path for sure.
He really did.
So let me just think. Oh, okay. So I wanted to ask you about the price for the equipment, so people have a clue.
Yeah. Well, the foam injection mixer is $159,
Wow.
and the foam generator is basically $500, or we also offer it as a kit for $350. And
I thought you were going to say something like in the thousands. That's
no,
amazing. That's amazing.
Yeah. We're getting ready to introduce a more efficient, it's a combination mixer pump. It produces 20 gallons of AirCrete every minute continuously.
Wow.
So for the contractor who wants to produce a lot of material, this is going to be really great. And it's just not quite. We still need to do more testing and get the manufacturing and everything set up. But that's probably going to be maybe a little over $1,000. But it's going to take it to a whole nother level.
Fantastic. Hajjar, I just want to say thank you. Thank you for what you're doing. Thank you for your innovation and your genius in making this available and accessible to people around the world. And we're just really grateful. I'm so delighted to share you with the world.
Okay. Well, thanks.
So thanks for being with us.
My pleasure. Thank you, Mira.
Thank you for joining us. Keep the momentum going by checking out all the other experts. Every one of them has invaluable information that you can't afford to miss. Buy the Premium Summit package now. Join the global conversation in our Facebook group and take action in your home, community, or the world at large. Together, we will shape a world that works.